Hi everybody, and in this video I want to continue our discussion of transforming sine and cosine functions, but this time I want to talk about horizontal transformations instead of vertical transformations. And it turns out that when you do horizontal transformations, that in these periodic functions, they're called phase shifts. Okay, phase shifts. That's what they're called. So a horizontal translation, when you shift something from left to right in a sinusoidal function, that's what we call a phase shift. I mean, you could call it a horizontal shift, but you should be aware of the fact that a lot of the time textbooks and teachers will refer to it as a phase shift, okay? So one of the most important things that you have to remember when you are applying a phase shift to a graph is that it's absolutely necessary to make sure that you extend your graph a little bit beyond what you normally would for your parent function. Let me show you what I mean so you understand this. So let's say, for instance, we have a situation where we are dealing with horizontally translating our sine function. All right, and let's say, for instance, that we are going to horizontally translate our sine function by 90 degrees to the left, 90 degrees to the left. So we need to horizontally or phase shift our sine function. Okay, horizontally phase shift sine function 90 degrees left. Now I want you to remember that on the x-axis we have degrees, and on the y-axis we just have like amplitude, okay? Or if you just prefer, you can just say the y values, y, okay? Like that's all it is. So if I'm talking about translating something 90 degrees left, think about what that means. On this graph, each tick mark represents 90 degrees, right? This is 90, that's 180, that's 270, that's 360, that's negative 90, that's negative 180. Okay, so like I'll just even write that in, 90, right? And that's negative 90. So just so you know that, all right? So now I'm going to erase that, but I just want you to keep that in mind. Yeah, well, it's not letting me erase it anymore. That's okay, I guess. I'll just deal with that. So just keep that in mind, because that's going to be important when we talk about these phase shifts. The other thing, okay, so you got the tick marks, right? Now, I've told you my very first point that I wanted to make was when you're making horizontal translations, or what we call phase shifts, the first important consideration is to extend your parent function beyond what you would normally extend it, okay? And you'll see why in a minute. But the second thing that most questions are asking you to do, and this is most textbooks and most teachers, they say, go ahead and do a horizontal translation and then graph your function between 0 and 360. So what they'll say is they want to see a picture of the graph where x, or your degrees, are done between 0 and 360. So watch, let's just explain this. If I was going to take my sine function and shift it 90 degrees to the left, that means the equation would be y equals sine, bracket x plus 90. That is telling somebody that you are taking your sine function and you're shifting it 90 degrees to the left. And we call that parameter that does that the d parameter. Okay, well, and it's actually, I should also mention that it's actually x minus d. So it's x minus d in the format, just kind of like vertex form from parabolas. It's ax minus h. So it's x minus d. So if I'm shifting a sine function 90 degrees left, I'm plugging in negative 90 for d, and then it's saying x minus negative 90, which is going to show up as x plus 90. Okay, so just to be clear, because I've obviously given you a lot of information here, if I am going to take a sine function and shift it 90 degrees to the left, in other words, a phase shift 90 degrees to the left, then what I need to do is understand that the equation for it would be y equals sine bracket x plus 90. Okay, so how do we go about and do this shift? Well, watch what happens. The first thing I do is I draw in my parent function. My parent function will simply be that sine function that I have hopefully memorized, right? So, here, 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 here. So it's going to look something like that. And then on the flip side over here, it'll do something like this, okay? So this is the sine function, all right, extended beyond 0 to 360. Now, if I'm going to shift it 90 degrees to the left, guess what? I'm going to take my key points that are in between 0 and 360 from here to here, and I'm going to move them to the left by one tick mark, because each tick mark is 90 degrees. So I'm going to take this point and I'm going to move it here. I'm going to take this point and I'm going to move it here. I'm going to take this point and I'm going to move it here. I'm going to take this point and I'm going to move it here. And I'm going to take this point and I'm going to move it here. But now I have a problem. Now, if I connect the x's, okay, if I connect the x's, you can see that I've started to draw it shifted left, but when they want us to graph the transform function, they want us to graph it between 0 and 360. But the problem is my graph stops at 270 because I took this point and moved it left. I took the point that was at 360 and moved it left 90. Now what do? Well, this is why I was saying it's so important that you draw the graph a little bit beyond, because now you take this point here, 450, and you move it one tick mark to the left. And now, look what you got. You've got your graph between 0 and 360, and this graph here, okay, this darker graph is the graph of y equals sine bracket x plus 90. It's been shifted correctly by 90 degrees to the left, okay? Let's do one more together and then we'll wrap up. So for instance, let's say that I'm dealing with a cosine graph. So we'll clear this sketch and let's say we have XY axis. So put a ruler in there, we'll draw this and we're gonna extend it. And let's have the graph of y equals cos x. We'll make it a little smaller than, normal, like just in terms of trying to fit it in. Okay, so we're going to try to graph y equals cos x minus 45. Okay, now what that means is we are shifting to the right by 45 degrees. Okay, we're shifting a cosine function to the right by 45 degrees. So let's go ahead and draw in our initial cosine function, which will look like this. But then let's take a moment to extend that cosine function to recognize that if we're going to be translating something horizontally, we're going to have something to translate. And if we just stopped our graph at 0 and 360, we'd be left out in the open with nothing to translate, okay? So the graph that you see on your screen right now is the graph of y equals cos x. It's our parent function for cos. And now I'm going to take my key values and I'm going to move them 45 degrees to the right. Now remember that each tick mark is 90, right? 90, 180, 270, 360. This is 90 right there. Okay, this is negative 90, this is negative 180. So if I'm shifting 45 degrees to the right, then I'm going to take my key points and I'm going to move them half a tick mark to the right. So this point will now be here. This point will now be here. This point will now be here. This point will now be like about there. Now, critical, this point will now be here, okay? And then all I am going to do is I'm going to connect my x's and see what I did? I connected my x's, and then if I want this graphed between 0 and 360, I can just then, if I want to, I guess, just take out my eraser or something and say, well, okay, that means the graph between 0 and 360 will basically look like that. Okay, so it's, and I'll highlight it in a darker pen. This will be really bold, but there's my graph, okay, between 0 and 360. And I've moved it, like I said, 45 degrees to the right. But remember, in order to do that, I needed to extend my original parent function beyond its normal 0 to 360 domain so that I had something to work with. If I didn't do that, I wouldn't have a point to work with. I'd be like trying to move something that didn't exist on my graph, which would be really hard. All right, I hope you found that helpful. We'll talk about it more in class. Thanks for watching.